Hello everyone. In this video, we're going to explain the four flags that is being used to in order to define the result of the calculation in the CPU level, which is negative, zero, carry, and overflow flags, and to see the examples how they work. So let's start by the sorry, by the understanding what those flags are. So as you see, they're standing for when the n is when the result is negative, z is when the result is zero, unsigned overflow when the borrowing happened, and signed overflow when the wrong sign has happened, which means that there is overflow. But actually, there is no the signing is not correct. So see the diagram, please, and when the calculation is happening in ALU unit of the CPU, and when the calculation is done, whether the result is zero, negative, or positive, it sets to this information to those four flags and pass it to branching. And the branching doesn't make any extra calculation in order to understand the result of the previous operation. It just checks the flags, so we can retrieve from the flag whether the result was zero or negative or positive. And the role of subtraction in comparison is very important because CPU, differ from high-level programming languages, which are using the smaller sign, greater sign, if statements, etc. But in CPU level, it uses simple method to compare numbers. It's used subtraction. So when we compare like 10 and 5, for example, it means that we're subtracting 5 from 10. It means that 10 minus 5. And based on the result, either Z flag is set to on or 1 when the result is 0. It means that compared numbers are equal. When the Z flag is cleared, it means that they are not equal. And if the N flag is not turned on, it means that the compared numbers A is greater than the B because their subtraction is positive number. And if the B is greater than N, when the A minus B is less than 0, it means that it's negative number and N flag is set to on. So let's see over the examples how those work. Here you see that first of all the greater or equal condition. And this condition is correct when the n XOR v, which means that negative and overflow flags have the same value, or they are both either 0 or either 1. So first we compared 10 and 5, both positive numbers. There is no overflow. When we subtract the CPU makes the subtraction 10 minus 5, result is 5, and there is no overflow. N and V are both set to 0. Their XOR is 0, condition met, and we know that the comparison is correct. When we do the negative numbers, you see here, we compare the minus 10 greater or equals than minus 5, which is not correct, we know, because the result is, minus 10 is less than minus 5. So when the CPU does the comparison, it means that minus 10 minus 5, minus sign here, and the result is minus 5, which is less than 0. Negative flag set to 1, and XOR and the V flag is still, there is no overflow, is set to 0. 1 XOR 0 equals to 1. The condition not met, so we know that this statement is not true. Let's see the overflow scenario. In overflow scenario, we compare that 127 is bigger than 1, and in arithmetic operation, since this result overflows to negative 128 here, and as a result, we know that the n is equal to 1 because the calculation result is negative, but there is v, which is overflow flag, is also 1, and their XOR is 1 XOR 1, which means it's 0. And this shows that this negative sign is not a real sign. Actually, it's a false sign. It's because of the overflow. So the statement is true. 127 is greater or equal than 1. Okay, let's move next. The next condition is less than condition, and in order to check that, it's just as greater or equals condition, but the n XOR v should be 1, not 0. So let's see the examples. 5 is less than 10 means that which is, if we subtract 10 from the 5, the result will be minus 5, which is negative number. N flag set to negative, sorry, 1, because there is the subtraction gives us a negative number, and v is 0 because there is no overflow, and 1 XOR 0 is 1 and condition met, so 10 is bigger than the 5. Let's see the overflow case. If we compare, like 1 is greater than negative or greater or equal than the negative 128, expected number is of course negative 129, but since this is 8-bit operation, it drops to positive 127. Here we don't get the negative number, but we know that the result should be negative. But negative flag is 0, but there is overflow occurred. So overflow is set to 1. It shows that the sign is not correct. It's false sign. So v is 0, but n is 0, but v is 1. So the result is 1, and condition met. This shows that when n and v are different, their values are different, the sign bit is unreliable. We cannot tell just because of the sign bit that the result is this or that. But the comparison is still valid because that v overflow flag, it shows that there is overflow. Let's move on. Condition code 3, greater than, and the condition is greater than 0, which is strictly greater than 0. There's no equal part. And it means that z flag should be 0 definitely, because we're not looking for zeros. And n XOR v should be 0 as well. So n and v should have the same value. Normal positive results, 10 is greater than 5. It means that 10 minus 5 will be, of course, positive 5. Negative flag is 0, v flag is 0, no overflow, and 0 flag, of course, 0. Everything is 0, and the condition met because their condition calculation is 0. When the result is 0, 10 is great. If we state that 10 is greater than 10, which is false because they are same numbers, subtraction happens to end up with the 0. So 0 flag set to 1 here. Sorry, as you see. And because of that, the whole operation will end up with 1 and 0 here. It means that the condition not met because we have 1 as a result of the operation. So let's move next. Negative result. When we compare 5, when we state that 5 is bigger than 10, which is false, of course, because the 5 is smaller than the 10, and their subtraction is minus 5. In this case, we don't even need the overflow and 0 flag to be checked because negative flag, n flag is set to 1. That automatically makes the calculation, the condition being not met here because of this. Let's move to condition 4, which is less or equal than 0. Here we will see this condition is true when either of these two statements are true. Z flag set to 1 or n XOR v is equal to 1, which means either the subtraction result is 0. In this case, 0 flag will set to 1, or n and v flags are different, so they're not sharing the same number. When the result is the case one, when the result is exactly 0, because we're comparing 5 to 5, their subtraction is 0. So we don't need the negative or V sign, I mean the V flag, the overflow flag, because Z is already 1. It means the whole condition 1. So the condition met. We don't need this part. And the negative results, when we compare, when we state that the 5 is bigger than 10, and that the 10 is bigger than 5, or we say that the 5 is less than equal to 10, it means that their subtraction will be minus 5, because of since the result is minus 5, zero flag is set to 0 because there is no 0, these numbers are not equal. But the negative flag is 1, which will make their XOR operations operation 0. So which will make their XOR 1 here, and 0 or 1 is equal 1, because one side of the OR statement is 1. It means the condition met. So now let's see the positive result here. We tell that 10 is less than 5, less or equal than 5, which is wrong. If we subtract it, the result will be 5. And since all the sides, the 0 flag is set to 0, and XOR V is also 0, the result of the OR statement is 0, which means the condition not met, because 10 is not less than 5 or equal. And the last one, we compare minus 128 and minus 1. Result is the result is positive 100 in 8-bit wise calculation. The result is positive 127. Which is not correct, actually. We expect negative number here, but this is positive number, but the V flag is set to 1. There's overflow happened here. So the Z flag is 0, naturally, there's no 0. One side of the OR is 0, but the other side of the OR statement, N XOR V, set to 1 because of this, because there is overflow happening in this calculation. So the condition met, actually, which means that negative 128 is less than minus 1. So in general, let's see the summary table. Greater or equal, sign it great, as you see. If we do the greater or equal condition, we're checking N XOR V, and the result should be 0 if the condition met. Otherwise, it's not correct. The statement is not correct. When we check the less than statement, it means that N XOR V should be equal to 1. It means that one of this flag should be 1. Either it's a negative or overflow. The third one is greater than. In this case, Z should be, and N XOR V should be should give us should be true, which means that Z should be either 0, greater than. It should be, I mean, Z and N XOR V should be properly ordered and must be not 0. So the last one is less or equal, which means that Z or N XOR V should be the one, because it's either 0 or a negative number. That's it. I hope it helps you understand this concept, negative, 0, carry, and overflow. Thank you for watching. Have a good day.